In this video, we're going to look at projectiles. So let's take a look at the first example. A particle P is projected from a point O on a horizontal plane with 28 meters per second with an angle of elevation of 30 degrees. After projection, the particle moves freely under gravity until it strikes the plane at a point A. Find the greatest height above the plane reached by P, the time of flight of P, and the distance OP. So the first thing we ought to do is to draw a diagram. So in mechanics, it's really important that you do draw a diagram. So we've got the origin here. A projectile moves, let's go back to the question, with a velocity of 28 meters per second. So we've got 28 meters per second. But don't forget, we can draw our projectile motion like so. And we can also split the components here. So horizontally and vertically. So now we need the angle. And they tell us it's 30 degrees. So let's draw that in. And we can resolve. So it's 28 cos 30 and 28 sine 30. Remember, the vector that contains the angle is always cosine. So it's 28 cos 30 and 28 sine 30. Now, what we want to do is to work out the greatest height reached by P above the plane. So we can now do a SUVAT, taking upwards as positive. So we've got minus G, U vertically is 28 sine 30, which is, in other words, 14. And at maximum height, velocity is 0, and we need to find displacement. So we can say V squared is U squared plus 2AS. So 0 is 14 squared minus 2GS. 2GS is 14 squared. So S is 14 squared over 2G. And that's going to give me 10 meters. Then part B says find the time of flight of P. So if we take upwards positive and do the SUVAT again, so it starts from 0 and it ends up at 0. So the displacement is still going to be 0. So U is 14, A is minus G, and you want to find the time. So we can say S is UT plus a half AT squared. So 0 is 14t minus a half G times T squared. So we can say half GT squared minus 14t is equal to 0. Factorize T out. So it's a half G T minus 14 equals 0. So we know initially at time 0 the displacement is 0, but here's the key thing, that half G T minus 14 equals 0. So we can say at that point half GT is equal to 14 gt is equal to 28. Therefore, t is equal to 28 over g. So we can work that out on our calculator. So that will give me 28 divided by 9.8, which is 2.86 seconds to 3SF. And then part C says, work out the distance OA. Well, this is the point A. So when you want to work out your distance horizontally, we can say the following. For part C, we can say, well, horizontally, S is equal to UT. Now, if we say it's plus a half AT squared, it moves with constant velocity horizontally. So we can say UT plus all of that goes to 0. So we can just simply say S is UT horizontally. So we know what S is. We know what U is horizontally. It's 28 cos 30. So, and we know the time. So it's going to be 28 cos 30 times 2.85, the true value of that, and we're going to round that to 3SF, so times that by 28 cos 30, and that will give me 69.3 meters to 3SF. And we put the 3 significant figures, and we're done. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So this question states, a particle is projected from a point O on a horizontal plane with speed 20 meters per second at an angle of elevation of 45 degrees. The particle moves freely under gravity until it strikes the ground at a point X. Find the greatest height above the plane reached by the particle and find the distance OX. So, as always in mechanics, we always start off by drawing a diagram. So we notice that a particle is projected from point O. So let's draw the point O here. It has a speed of 20 meters per second. So don't forget, this velocity can be drawn into components. So let's make our projectile like this. This is the point X. Now, don't forget they tell us that the angle involved is 45 degrees. And we need to resolve our velocity into its horizontal and vertical components, respectively. Like so. So we're going to draw this like this. So we know that this is 20 cos 45 and this is 20 sine 45. Now, part 8 of the question states, find the greatest height above the plane reached by the particle. So let's do a suvat, taking upwards as positive. So let's do a suvat here. So vertically, we've got 20 sine 45. We're trying to find S. At maximum height, V is 0, and we've got minus G. So we can use the suvat equation, V squared equals U squared plus 2AS. So therefore, 0 squared is 20 sine 45 all squared minus 2GS, and we get 2gs equals 20 sine 45 all squared, and we're going to divide the result by 2g. So we can do 20 sine 45 all squared divided by 2g, and we can get our answer on our calculator. So that's going to give me, if we move my calculator over here, and we're going to round our answer to 3 significant figures. So 20 times sine 45 all squared divided by 2 times 9.8. And that's going to give me 10.2 meters to 3SF. So to 3 significant figures. And then lastly, the question states, just close the bracket there, find the distance OX, as in the horizontal distance. And we did this last time in the previous example. So what we need is the time of flight. So we can do this in 2 ways. Because this is symmetrical, we could do what we did last time and say, let's do this in the way we did in the previous example. So taking upwards is positive, S is going to be 0 because it starts at the origin and finishes at the origin. As in the origin, just be clear, it starts here, as in that's the origin, and that's also 0 in terms of displacement, because displacement is a vector. So S is 0, U is going to be 20 cos 45, and you can get that from our diagram here, the horizontal component of the velocity, and what we need is the time. So we can say S equals ut plus a half at squared. So S equals 20 cos 45 t minus, don't forget we've also got minus g, so it's minus half gt squared, and don't forget S is 0, so we can say a half gt squared minus 20 cos 45t equals 0, and then we can factorize this to give me t and a half gt minus 20 cos 45, like so, equals 0. So therefore t equals 0, or half g t minus 20 cos 45 equals 0. Now we can solve for this, so we can say that implies that 20 cos 45 over half of g will give me the value of t that I'm looking for. When t equals 0, it's already at the origin, and then it returns back to the origin at this time point that we're going to calculate, which is going to be 20 times cos 45 over 4.9, which is half of 9.8. So I get 2.89 seconds to 3 significant figures. So now what we need is the displacement horizontally, and we need to use the true value. So I'm going to put 2.88 and so on. So horizontally, we need the SUVAT formula S equals ut. As I explained in the previous example, that a will be 0 because it's constant velocity. So we can say that's going to be the following. It's going to be the horizontal component of the velocity, which is 20 cos 45, times the time we just worked out. So it's going to be 20 cos 45 times 2.88, and so on, the true value of that. And we're going to round that to 3SF. So we could do that times by 20 cos 45, and that will give me the answer I'm looking for, which is going to be 40.8 meters to 3SF.